Question 5. This is the reactions between the persulfate and the iodide form the sulfate and iodine. The rate of reaction 1 is investigated. Okay, a sample of this persulfate is mixed with a large excess of iodide of known concentration. So let's move on to the question what they want. Part 1. Use a figure 5.1 to determine initial rates of reaction 1. Initial rate means when t equal to 0. So you need to draw a tangent, right? Tangent at t equal to 0. So means from this initial concentration, right? So draw a tangent, and after that you get the gradient. So the rate is you just use this 0.8, the initial concentration here, right? Here, and over 25. After draw tangent, you should get the time at the x-axis. So for mine, I get 25. So 0.8 over 25 minutes. So it's 0.032 mole per dm cube per minute. Okay, this one is quite easy. Part 2. The rate equations for the reaction 1 is given. So rate equal to the K constant times concentration of persulfate times concentration of iodide. Suggest why a large excess of iodide allowed the rate constant to be measured from the half-life of this investigation. This one is because when we use the excess of iodide means this one is constant. So we assume this is constant. So when it's a constant, then it's kind of like we assume it's 1, means it has really no effects on the rate. So the rate now is just depends on the concentration of persulfate. So that's why we can use the concentration of persulfate to get the this half-life and so on. Okay, that's the reason why, because this one when it's in last excess, so it's always constant. So it's constant means now the rate is only depends on the others, okay, which is the persulfate now. Okay, part B. The reaction of persulfate ion with iodide is catalyzed by iron 2. Okay, this one you need to refer back to the overall equation just now, because in this reaction is catalyzed by the iron 2, and you need to know the reactants and products. Okay, we know that persulfate is formed sulfate. So we know that this one is get reduced, and the iodide now form iodine, so it's get oxidized. So means persulfate reduce, iodide oxidized, and we need to use this overall to get these two equations from the reaction with the catalyst. Okay, so now we know that now persulfate is need to reduce to sulfate, means when persulfate reacts with this catalyst, so it needs to oxidize the catalyst. If the catalyst that using now is iron 2, so iron 2 need to be oxidized to iron 3. Okay, so that's the logic there. So means you need to put the persulfate, okay, form the sulfate first. Then you put the iron 2, because the persulfate must react with iron 2, because the persulfate need to reduce and is oxidized others. So it's oxidized iron 2 to iron 3. Okay, then you just balance it. Okay, put the 2 moles of sulfate and 2 moles of this iron 2 and iron 3. Okay, after that, you need to bring this iron 3 for the second equation. And of course, this iron 3 now reacts with iodide. We know that iodide is being oxidized to iodine. So when it's oxidized means it's going to reduce others. So in this case, it need to reduce the iron 3. Okay, so iodide now reduce iron 3 and iodine get oxidized to iodide, get oxidized to iodine, and iron 3 now reduced to iron 2. Okay, you just balance it. So put 2, okay, for the iodide, and 2 for this iron 3 and iron 2. Okay, that's how you form the two equations. Okay, describe the effect of an increase in temperatures on the rate constant and rate equation, rate of reactions one. This one is quite simple and quite direct. We know that when temperature increase, the rate must increase. This is for sure. So if let's say we recall back the rate equations that given. So when rate increase, means when temperature increase, rate increase. If the concentration of persulfate is constant, means same, because rate already now increased, the rate constant, therefore it must increase. If this concentration of persulfate is stay the same, so it's quite easy. So therefore, the both rate constant and the rate of reactions will increase because of that. Part D. In aqueous solution, thiosulfate reacts with hydrogen ion, shown in reaction 2. This is another question already, another reaction. It's about thiosulfate, not persulfate. Okay, now, thiosulfate react with H+, form SO2, sulfur, and H2O. The rate of reaction is a first order with respect to the thiosulfate and zero order with respect to H+. Okay, it means something like this. Rate equal to K constant times concentration of thiosulfate only. And the rate constant for these reactions given is 1.58 times 10 power negative 2. Okay, therefore, after that, calculate the half-life for this reaction 2. So, of course, you need to memorize this. How to calculate the half-life for the first order reaction. Whenever the reaction is first order, you can get the half-life using this formula. So it's 0.693 over the K constant of the reaction. Okay, so the K constant is given, you just substitute to this, right? So you get 43.9 seconds. Again, the half-life for this first order reaction, okay, we can use this formula. Okay, last one, E. The compound nitrosyl bromide NOBr can be formed as shown in reaction 3. So this is the overall reaction equation given. The rate is first order with respect to NO and the first order with respect to the bromine. And the reaction mechanism has 2 steps. So suggest equations for the 2 steps and state the rate determining step. So first, the rate equations is equal to what? Rate equal to K times concentration of the NO and times concentration of the bromine. If we want to to get these two step or these equations, okay, first we need to know which step we need to make it as the rate determining steps. Okay, let's say step 1 is the rate determining step. So we must make sure the moles of NO and the bromine must be 1 mole each. Okay, if let's say this is the rate determining steps, we must make sure the reactant site here only 1 mole of the NO and 1 mole of bromine. So therefore, it can fit this rate equation. Because when the rate determining steps is there, the reactants, the most of reactants will represent the order. Okay. So if you put 1 mole of NO and 1 mole of bromine, means okay, is fit these rate equations. Okay. So you start from here. Mixture is 1 mole each. So next step is you need to put the product. The product is 2NOBr. You put the products in the second equation, the product side. Okay, then you complete the two equation. So you start with this one, continue by this one. Okay, after that, it's quite easy. You just put these two together. So it's NOBr2. This is the intermediate. Then you bring this intermediate to the second step, and you put the NO here. Why? Because in this overall equation, there are two NO in this equation. So you need to put another NO in second step, because this NO will not really contribute to the orders now. Okay, then after that, the intermediates now is cancel out, and there are two NO and one bromine to form 2NOBr. Okay, that's how you form the two steps, okay, from the rate equations and with the specific rate determining steps. Okay, that's all. Thank you.